Hello, everybody. Good afternoon. Today I would like to present to you the application of Particleworks by us at Powertrain, Germany. The approach that I took was with a little of management topics. And also regarding the selection of Particleworks as our software of choice for our development of EDUs. So I rotate, yeah. The title. It's about the development of the product that we have at Powertrain, Germany, which is the EDUs, the electrical drive units. PCP stays from product creation process. Long story short, it's just a development process that we have at home. No? So I will present the journey that we took to select Particleworks at Powertrain, Germany. I divide the agenda in three parts. First, to present to you who we are and what we do. The second two, maybe it's not that clear, but I try to do it. So this two is about to present a little of management, how the development of a product take place by us, which sometimes it's not that well tackled, but it is as important as a simulation to have a good communication between the departments, between the management, between the project, and of course not to forget our process flow. No? So at the end, the application of Particleworks that I've been working on with the help of the Particleworks team support, and which will draw some conclusions regarding the application. Powertrain is a global company that develops transmissions or powertrains, as the name says. There. We have three main products, being CVT, DCT, and EDUs, or electrical powertrains. These are developed in Germany by us at home, from the design onto the prototyping and the validation of the design. No? That will be the topic of today. What is an EDU? For the people who might not be familiar, or I suppose that most of you are at least from the trends nowadays of electromobility, kind of know what it's all about. That is an electric drive unit. It composed to three subsystems: the electrical, the electronical, and the mechanical. As I mentioned, we do the old research. I do all the simulations of the drive unit. For example, for the stator, the cooling of the end windings, which was presented yesterday, I guess. We need also the simulation, and I performed simulation for the rotor cooling. It's a quite interesting system that takes oil from the gearbox to cool the magnets at some working points, and not, of course, not for all the applications or for all the clients. Housing, it is not only the piece of aluminum, but it is also quite complex casting part that, as any one of you mentioned previously, where the design should be as good as the oil dynamics in the housing are properly for the lubrication and the cooling of the whole system as it is. We have external cooling, internal cooling, active passing lubrication according to what the requirements are from the client. Sometimes we have heat exchanger or without heat exchanger through the housing, through the aluminum, come the conduction. So it is kind of quite interesting topic in the area of mechanical engineering. Last but not least, and the specific topic of today, gear train simulation. I've been performing these simulations with a couple of software, and ending up with a selection of choice for Particleworks. Be aware, and let's not forget that it's not only about the lubrication of the gearing, lubrication of bearings, but also of the functioning of the whole system. the thing that you see here, for example, the spray of wet motors, come from the same oil of the gear train. Some whatever big companies, I might not say the name, but some of them they use only oil for cooling the whole motor. Therefore, it's important to have the flow solution as good as possible in this area. And yeah, another example, just very quick, for example, for the rotor as well. So the oil that is cooling the rotor when it is needed is come also from this part. Yeah? And a little about organization, management, if you want to call it like that. On the left side, our process development. It is nothing special. It's quite standard for the whole companies. It is not necessarily this one, but it captures what it is by us, and I guess by many of you at the house. These are the three stages where we have the application of simulation and also testing, but in this case simulation. Previously, of course, we have the client acquisition or the production, whatever. But these are the three main parts where the simulation must be really working together with the management, really working together with the testing and with the develop of the product, not only be a part separated as a CAE department. No? So this is the approach that we had previously, and we didn't want to have it at Powertrain Germany. We see a separation, which unfortunately is still nowadays common after some benchmarking that we also do. Hope it's not your case, but yeah, this separation decouple at some points the communication between the project management, between the people that looks on the overview as system engineers or architects, and the CAE engineers, or as myself, lead engineer, somewhere in between. This separation is not that nice to have. Without mentioning that inside also we have sometimes the coupling of the understanding of the physics and the numerics. So this kind of thing we wanted to avoid in Germany, and we were looking for a software that gives us this coupling and this integration, where I can have a rather compact team which work in a rather compact system, which is the EDUs. No? So therefore, and to remark, it is for our application. I know today were a lot of application presented, but for our application as EDU, we're talking about 1.2 liters, whatever. No clutch, not complicated mechanics, only the reducer. Of course, there are versions with more complexity, but from the big companies to the middle companies, it is the way to choose only quite compact system. Yeah, not to forget that we have also our own process in the CAE. When we follow it properly, we have these three. I just highlight the pre-processing because it is. I hope you agree with me, but the most complex, or at least where we have to interact with the software. So I guess we all know of this, but it is important to have it in mind. And it is about the geometry treatment or the checking up. Sometimes we have to make some modifications of the components, simplifications for the approach that we used to have and that we didn't want to have at Powertrain Germany with the EDU development. This is what we came to. What we are looking here is the development that we did in Germany for ELCB motors. ELCB is nothing but the motor designed for the trucks that are developing for or delivering the package to your home. So this stands for light commercial vehicle with its own needs. What I implemented here with Particleworks was the first approach of seeing how the software can help us and if it was the right one for us. And this is the result. So keeping in mind what I presented before, the geometry is just reduced to the barely minimum. We don't have more pinching or more little problems for the meshing or for the extraction of volume. The mesh is gone completely. and only the physics boundary condition are there, which only is the introduction of the values, which we should do it with a technical physics, keeping in mind the physics and not only the numbers. I will not go much into the details of what exactly we're looking there, or the boundary conditions that I just skipped right now. But this is one of the first simulation that I did with the support of the team of Particleworks regarding this motor. Now we have a transparent housing in our prototype workshop. And what you can see here is that we capture the flow solution, which is the very first and the foundation of what we want on the way to, we call it virtual prototype, or whatever other approach that you have or would like to have, in which the physics and the numerics are related as much as possible. You are not going to decouple 100%, or at least not in the near future. We are of the opinion that we will need to use, of course, testing, and this is the step number one, to have a flow solution that, for example, here the splash into the gear housing is captured qualitatively good. That afterwards is going to impact in the thermodynamics of the whole system. Here we see the pressure of the pressure side and suction side of the differential, which at the end impacts in the oil level, which we have a good qualitative agreement. As you can see here, maybe the perspective is not the best in here because of the camera, but believe me, this is quite good, the level. We have the measurements. I just want to put it in this video that says a lot more than many words. No? So one other physics that at the beginning was not that interesting, some dropping in some area, but at one stage of the design was important to know that we have something like that, and some design decisions were made afterwards. It was important to know that with Particleworks we have that as well. No? So these kind of things, again, the flow solution capture is the thing that is our fundament in the looking for the software back then. And yeah, maybe I didn't explain the detail, but in principle, the challenge in this motor, in this design, was that our client, or even for ourselves, sometimes we want to test specific things like the backward driving condition, which is in this case the case. For the differential, for example, in the normal design of this motor, it's going on the other side, on the other direction, and it's splash the oil in the reservoir on the differential when the car is driving in from left to right. In this case, we are driving from right to left. So for whatever condition that maybe the client would like to mount the motor in whatever position, or to investigate the drive backwards condition. No? So we can see here we took some design in our group in Germany, and we put some components there to allow us to have the reservoir filled with the intermediate shaft. Yeah, here we can see that it is not qualitative but quantitative. A good match with the experiments. I could tell you was up to the plus minus couple of kilometers per hour vehicle speed. No? Why it is important? As I mentioned previously, the system, what is needed, it is not only the lubrication of gearing bearings, is more complex. So therefore, it is important even our low, medium, or medium high velocities. And another example, the same story. We reduced our preprocessing we have to remark in here that all of the components and all of the interactions were considered, which is something that take us closer to what we want. In our case, is to have the numerics and the physics as close as possible. We didn't want to make whatever treatment of the gearing or of treatment of the bearing or whatever other thing that it was done outside Punch Powertrain Germany. So this is the type of another example for, in this case, for PKW or passenger cars. This is for the cars that we drive every day. So with their own specifications from the client. In this, what we are seeing is kind of a similar story. For the clients and for us, was important to know when and how much oil we're going to have in the reservoir. For a specific reason in this case, for example, the feeding with oil of the system of the rotor cooling. In here we have some in the Z axis we have a hole which goes through the rotor and cool down the bearings. There is an approach is already investigated for many of the electromobility companies in the business. So in there we demonstrate. I didn't put all of them, but I have here the original 1, 2, 3 design up to the 4th. We conclude that only the design 4 was the one to use as the requirements of whatever kilometers per hour vehicle speed requires. Because sometimes it's not only important to test or to design to high power. High power is normally designed in a way that the thermal mass of the motor also gathers some heat. Yeah, as we see, we have in the test, you can imagine how much it costs for the 3D printer, for the people and in the test bench, for the mounting, and for the concluding of the 3 designs that we did didn't work, but the 4th having the very same results with numerics. No? So, and important also, I measure at least 13 times faster. No? We can take that as reference because yeah, even at particle size, we can take it as reference because all other parameters are linear dependent. So that was our case for our application. Yeah, last but not least, we did also some convergency study. We can see, of course, there will be some difference, just like in the mesh. The thing is not to replace the test, as I mentioned, but to approach as much as possible to the virtual prototype that we want, starting by having a flow solution, which is for our research and development team, that we are agree and confident with them, understanding the numerics and the physics together to know where what we need. For example, if we want to gather the precise measure of the oiling, maybe we need another, or not maybe, of course, we need another particle size. If we want the general dynamics, we need another. So we can see here some convergence study, which in principle tells that yeah, the particle works and converge. The values are in the very range that we are expecting. And yeah, that is from my side. Last but not least, the conclusions. After what we present, what Particleworks allowed us was to have a reduction in the time, not only the post-processing, but also in the solutions to, let's say, at least 13 times faster than what we that it was done outside Punch Powertrain in Germany. And then, of course, the flow solution. So Particleworks shows that can take us closer to the virtual prototyping. And yeah, some numbers there. I measure the time of with the finite volume methods. We have actually not only one, but another test from another providers in the area of finite volume, and these are the numbers I came out from. So it's a dramatical reduction of the time as a whole of the process. And if you can consider also the process within the process, which is the development, therefore we need a software that take together the whole as a team, and not to be taking too much time in the software usage and having this linkage of the physics and numerics, and taking more time on how to use a software rather than as an engineer and as an R&D team, as lead engineer, to have my time of having an impact in the whole. No? Yeah. Last but not least, we are continuing forward. I am using Particleworks also for PGS, for churning losses. Here with multi-resolution for the sum, the testing of multi-resolution for the bearings, for the clutch, and some benchmarkings. I think the time is running up, but I wish I could explain this, but I think the image says a lot. So there was a solution that one very well-known company approached to us for electrical drive unit development, and at the end they were as cumbersome as the normal software. They call it in another way for reducers for electrical drive units. But the treatment was so cumbersome that as making the mesh and so on, and of course the flow solution was captured in a low quality, without mentioning that it was still by far slower than on what we have on the right side with Particleworks. Thank you.